is the same as this distance. Chords that are the same length are the same distance. Oops, nope, I drew the wrong one. Are the same length from the middle. So if you drop a perp, right, from those chords to the center, do you see how these are perpendicular and go to the center? Perpendicular goes to the center. These two lengths need to be the same distance. And it told us that one was 5x, that CU was 5x, and CV was 6x minus 7. So did we set those equal to each other?
Yes.
Perfect. Did we subtract 6x from both sides?
Yeah.
And we should have gotten negative x equals negative 7. X equals 7. Did we get that?
Yeah.
Let's go. We're not done though. Why not? Find the radius, okay? So we have to plug that back in. You should get 35 for each of these, yes? Okay? So once we get that 35, we then have to set up a right triangle, okay? So you could have drawn any of the following 4 lines. You could have drawn QC, CR, CT, or CS. Any of these will give you a right triangle, okay? I'm just going to go ahead and draw CVT. I know that this is 35, but the bottom side from V to T is not 240. How much is that distance? It's 120. Why do we divide it by 2? It's bisected, okay? So we divide it by 2, it gets to be 120, and then we set up our ABC. What's the hypotenuse here? X, okay? Make sure your C value is your hypotenuse. So x squared is going to be equal to 35 squared plus 120 squared. And you're going to get x squared equals 35 squared. This is why we have calculators. Is 1,225. Plus 120 squared is 14,400. You add them together and we get 15,625. X squared equals 15,625. Is that my radius?
No.
Why not? Square root. Okay, take the square root of both sides. We're going to get x equals. You take the square root of that answer, and you are going to get 125. This is a Pythagorean triple. Why is it a Pythagorean triple? They're all whole numbers. Very good. So we've got 125 over here, and that was our answer. Did everyone pick B? Now we picked B. Okay. This was on the quiz. Did we get it right? No, we didn't get this one.
I got 7.
We got half right. Did we at least set the x terms equal to each other?
Yeah.
Okay. Xavier? Yes. Okay. Are there any questions now that we went over this question, though? Any questions about it? We're Gucci? All right. Chapter 10, Section 4. Inscribed angles and polygons, okay? All right, so guys, in total in chapter 10, which is all about circles, there are 6 lessons, okay? So we have 3 more before our test, all right? This lesson is about inscribed angles and intercepted arcs, okay? An angle whose vertex is on a circle and whose sides contain chords of the circle, and an arc that lies between 2 lines or rays or segments, okay? So now we're looking at angles. But before, all of our angles, their vertex was where? Where was the vertex of all the angles we've looked at before? In the middle, okay? So I want you to draw the middle so that you can see and draw a little note to yourself. The vertex is no longer in the middle. Okay, so before, right, we called those central angles because their vertex was in the center. Do you guys remember that? But now our vertex is on the edge of the circle. Do you guys see that? This angle is no longer the same measure as the arc. Okay, so if the vertex is in the center, do you guys remember, like, if this was 90 degrees, the angle, then this arc was also 90? That no longer happens when your vertex is over on the edge, okay? We have to apply a new formula. Are you guys okay with knowing, like, if your vertex is not in the middle, it's not the same, okay? So I agree, right? If our vertex was here, right, and we drew an angle here, this angle is going to be the same as this arc. We're all in agreement there, okay? The angle is going to be the same as the arc. But when your vertex goes away from the middle, right, and to the edge of the circle, they're different. Understood? Okay, now I'm going to show you how to calculate it. The measure of an inscribed angle theorem. The measure of an inscribed angle is 1/2 the measure of its intercepted arc, okay? It's exactly 1/2 of the intercepted arc. So let's say the arc AC was 100 degrees, right? Then we would know angle B is exactly half of that. What's half of 100? 50, okay? So let's just go ahead and fill that in so you guys know. If AC was 100 degrees, for example, okay, you would take that 100, divide it by 2, and now you would get 50 degrees in here, okay? And I want you to add one extra thing. Draw the center, and then draw 2 extra lines going to A and C. Does anyone think they could tell me what this angle is if it started in the center? It's not 75. Christian? Why is it 100? Very good, okay? Do you guys see the difference here? So when our vertex is in the center, it's the same as the arc. Make sense? But when we move the vertex away from the center, right, doesn't our angle become a lot smaller? And it becomes smaller by exactly half, okay? Now, this only works if your vertex is actually on the edge of the circle, okay? If your vertex was like here, and you drew 2 lines, or 2 angles, let me use a different color because that's gonna get confusing. Let's say we had like an angle here. Do you see how the vertex is not at the edge of the circle? We don't really have a way yet to calculate this angle. So you won't see an example like that, okay? So the vertex has to either lie in the middle, then it's the same as your arc, or on the edge of the circle, and then you know it's 1/2. Make sense? Okay. Any questions? All right, so if we were given the angle, right, 50, what would we have to do to figure out the arc length? We're not dividing anymore.
Multiply.
Multiply it by 2, okay? So if you're given this angle, you just multiply it by 2. So we take 50, multiply it by 2, and we get the 100. Make sense? Okay. Wait, does yours have the inscribed angles of a circle theorem? If 2 inscribed angles of a circle intercept the same arc, then the angles are congruent. So,
You don't actually make it up, you actually follow something?
So, angle 1 and angle 2 are the same. How could we prove that they're the same? Talk about it in your groups. Go. What's that? Alternate exterior. Well, we don't have a pair of parallel lines, so we can't apply that here. Emma?
They're both on the edge of the circle.
I love that. Okay, go ahead. Okay, use a different color. Put that the edge. They both their vertexes are on the edge. Do we see that?
Yes.
Good. So that helps us. That helps us get started. What else do we notice? Emma, did you notice anything else?
They both go to the same points and they both have the same arc.
Bingo. They both have the same arc. Check this out, okay? Use one color for A and draw the angle that creates angle 1. Do you guys see that? Are we all in agreement that angle 1 creates that arc from A to B? Yes? Use a different color and draw the angle 2. Oh, that's a terrible color to use. Do you guys see how each of these form the arc AB? Do we see that?
Yeah.
So, angle 1 is exactly half the measure of the arc AB. Angle 2 is going to be also exactly half the measure of the arc AB. Yes? Because they both intersect at the same arc. okay? We can draw a third angle. Go ahead and draw a third angle. Let's do it in yellow. Down here, and draw it to A and to B. And we'll label it angle 3. Is angle 3 also the same measure?
Yeah.
It is, okay? Because if you take the arc, right, which is AB, formed by the angle, and you divide it by 2, you will get the measure of angle 3. If you take AB, right, the arc measure, and you divide it by 2, you're going to get the same angle, which will be angle 3. Okay? So sometimes it's helpful, guys, to use different colors to identify your different angles. Do you see how I wrote angle 2 in a different color than I did angle 1? That can help you visualize it, okay? All right, let's go ahead and do a few examples down here. So you guys have the examples, right? You don't?
Oh, wait, no.
No.
No? Is the angle, right? The angle is the red one. What would be the measure? Oops. What would be the measure of the angle HGF? Emma? 45. Why? Good. You take 90 divided by 2 and you get 45 degrees. Very good. Okay? What would be the measure of the arc? Bless you, bless you.
Thank you.
Of the arc VT. Mariana? 76. Why? Good. You take 38 and you multiply it by 2 and you get 76. Excellent. All right. What would be the measure of the angle ZXW? This is the hard one. The measure of the angle ZXW.
72.
Why is it 72?
Because of the thing we just did.
The thing we just did, okay? Do you guys see how, if you want to use a different color, ZYW forms the same arc as this angle, ZXW? Do you guys see that? So this arc, regardless of what amount it is, we know it's 72 times 2, but we're going to get the same angle over here. Agreed? So that angle must also be 72 degrees. Emma?
So, angle YZX and XWY, I'm assuming?
YZX and XWY. Yeah,
Yeah.
very good. So Emma's saying you can also flip it so this angle is the same measure as this angle. Very good. Is there another one? Well, if we drew, yeah. Very good. Okay. Any questions? All right. Inscribed polygon and circumscribed circle, okay? An inscribed polygon is a polygon with all of its vertices on a circle. And a circumscribed circle is the circle that contains the vertices of an inscribed polygon, okay? So the red circles are what we consider circumscribed circles because they completely consume the figure, right? Every vertice of that figure lies on the circle, okay? And then the inscribed means it's inside, right? So inscribed, you may want to write a note to yourself how to remember that, would be inside. It lies inside the circle. So all the vertices are on the edge of the circle and the shape is inside the circle. Okay? There's no part of the shape that's outside the circle. So let's just draw one extra figure to show you what is not circumscribed. Draw a circle and then draw a triangle with 2 vertices on the edge and 1 outside. Do you see how this is no longer inscribed? Because one vertice is outside. Okay? Another example of what wouldn't work would be if you drew a circle, right? And you had 2 inside, but 1 that was not on the edge. Both of these are not examples of inscribed or circumscribed. Okay? All of the vertices need to be on the edge of the circle. Okay. Next, what I want you guys to do on this slide is I want you to draw a triangle inside a circle with one of the sides being a diameter. Okay? So start, you can draw your diameter anywhere, but put the center down and draw a diameter that goes through that center. So from one edge of the circle to the other. And then draw any triangle from there. But remember, it has to be inscribed. So you have to have that last vertex somewhere on the edge of your circle. So I'm going to draw mine here. And I'm going to put this and this. Do not copy mine. Make yours different. Put your vertex somewhere else. It could be on the bottom. It could be somewhere else. Okay? Yeah, that works. Okay? Everyone, the angle that formed from that third vertex is 90 degrees. I don't care what triangle you drew. The angle that formed when you drew your triangle is 90 degrees. And I want you guys to think about why. In your groups, talk about it. Why did everyone that just drew this picture, the triangle that you drew, that angle at the top or the bottom that you just created is 90 degrees for all of you? Talk about it. Go. Does anyone think they know why this happens? Xavier? Half of 180 is 90. Very good. But why'd you pick 180? Where's the 180?
Straight line, the diameter.
The diameter. So what about it?
So the arc it makes is 180 degrees.
Excellent. So check this out, guys, okay? Everyone take a highlighter and highlight the side of the circle that's opposite your 90 degrees. Okay, hold on. Do you guys see how this angle right here forms this arc on the circle? Yes? And how much is that arc, Xavier? It's 180. And in order to find the angle that created it, you do what? Divide by 2. So that angle has to be 90 degrees, okay? Now, the cool part is you guys could have drawn any right triangle in there, right? I told you pick whatever vertex you want. So for any right triangle, okay, if you are to circumscribe a circle around it, the hypotenuse will always be the diameter, okay? The hypotenuse will always be the diameter, okay? Because of this fact that your hypotenuse has to be the diameter in order to create that 90-degree angle. Cool, right? All right. And that's our next, and I think last theorem, okay? If a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. Conversely, if one side of an inscribed triangle is a diameter of the circle, then the triangle is a right triangle and the angle opposite the diameter is a right angle, okay? So in other words, the measure of angle ABC is 90 if and only if AC is the diameter of the circle. And guys, we just proved this, okay? So if you were on the right track in noticing that the arc was 180, you just did a proof, okay? An inscribed quadrilateral theorem, okay? A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. What does supplementary mean again? They add up to 180, okay? Write a little note for yourself in case you forgot that. Add to 180 degrees, okay? So remember, opposite angles are going to lie opposite each other. So the two opposite angles here would be, for example, 1 and 3, yes? So 1 and 3 must add up to 180. And the other two would be 2 and 4. So 2 and 4 must add up to 180. Okay? Now, this is a little bit confusing because when we talked about parallelograms, adjacent angles added up to 180. Adjacent angles were supplementary, okay? But when we're circumscribing in a circle, okay, the opposite angles add up to 180. So, useful fact number 1, an angle inscribed in a semicircle is a right angle. We already talked about this, right? Okay? So, as long as the two sides of your angle right, form a semicircle, then it's a right angle. Okay, so we can draw a perp here. Oops. We can draw a perpendicular angle here. Okay. And then some examples to finish off. Okay. Find the values of x and y in circle O.
Wait, do we need to like cut the triangles?
Okay, I agree with you. I see Talia writing down some stuff. So let's go ahead and draw the angles back. You drew this. Okay, I like it. This angle, it says, is 20 degrees, right? Does that help us? How? Y is congruent. But remember, y is both of these, right?
Oh, I
So
thought
y
I
is
was
this whole
the
thing, okay? The 20 is just this smaller section, okay? This diagram's a little bit confusing. But do you guys see where x is? X is right here, right? Could we figure out x? How? X is 40, why? Yeah, you just take the inscribed angle, multiply it by 2. So x is going to be 20 times 2, which is 40 degrees. Okay, let me walk you through that one more time. So start at the arc, right? Take the angle that it goes back to, right? And that's 20. So this has to be double it, which would be 40. What else needs to be 40 degrees? Xavier?
Sorry.
Or what would you do next?
Oh, I was gonna find y next.
How would you find y?
So y has, like, the smaller angle of y has to be 20,
Okay,
and then the bigger one you find by dividing 110 into,
very good.
and then you add them together.
Very good. Okay. So, do you guys see the angle y is this whole thing right here? Yes? But that is this whole arc. Agreed?
Yeah.
So we have to add this arc with this arc, which will give us, I believe, 150, right? And then divide that by 2. So what's the measure of angle y? 75. Okay? Because you had to add both of these arcs together, right? To create that 75. Okay? Because angle y is larger. Yeah, go ahead, Talia.
What did you add?
I added 110 and 40 to give me the full arc, right? Going from this point to this point. And then I divided it by 2 to figure out the 75. Now, there's a lot of intersecting lines here, right? So it can definitely get confusing, okay? Make sure that you guys, if you need to, just redraw it, okay? Draw another circle and just look at the angle that you're looking for. So you could totally just draw another circle and just put x in here, right? And then be like, okay, what did I know? I knew that this was 20 degrees, right? And then that's like, oh, this is easy. Then this needs to be 40 degrees. And then add extra lines after that, okay? But take it as slow as you need to, okay? And draw it as basic as you need to. All right, B. Emma, what are you thinking?
So x is 20 degrees because it shares the same arc as the other one.
Very good.
Y is 90. 'cause
Y.
it's a semicircle.
Very good, okay? So do you guys see how this is a diameter? And y is the inscribed angle here? This has to be a right triangle, so y must equal 90 degrees. Excellent. Questions on that one?
Wait, where's the 90?
Okay, so this is a diameter, do you agree?
Yeah.
So the angle, right, that intersects or has the two endpoints there, it must be a 90-degree angle. So the whole thing must be 90. Yep. Okay. Yeah.
The diameter, does that run through the center point
Yes, it has to go through the center
in order to have
in order to be a diameter. Mm-hmm. All right. Any other questions? All right. Do you guys have this slide? All right. What do you think we do for C?
140.
What's 140?
140 plus 60 divided by 2.
Well, 140, we divided by 2, that would give us this angle. Do you guys agree? It should be 70 degrees. Emma?
And then you add 70 and 60 and subtract it from 180.
180, because it's a triangle, right? This is a triangle. Do you guys agree? And triangles in total have 180 degrees. So we did 180 minus 60 minus 70. And we got 50. So this is 50 degrees. All right, but remember, we're looking for X and Y. How can we figure out X and Y? Jaden?
So, you know, the 60 is that, you know, 60 is that, and the opposite arc would be X, right?
Yep.
So then you would go 60 times 2.
Good. So X is going to be 60 times 2, which is, we have calculators, 120, right? All right. Emma?
And then for y, it's 50 times 2, so it's 100.
How could I check that I got those right? Anna? Very good. I could add all the arcs and make sure that they add up to 360. Very good. Okay. So 100 plus 140 plus 120. Does it equal 360? It sure does. So we know that we are correctamundo. Yes. Yes. So I got 50 from doing 60 plus 70 or doing 180 minus 60 minus 70. Okay? Because remember, inside this triangle, there's only 180 degrees to deal with. Okay? All right. What are we thinking for D? Good. Divide 80 by 2, and we should get what? 40 degrees. Are there any ideas on what to do for Y? Sophia?
First, you add 2 degrees to get 160. Then you would subtract it from 360, and then divide that by 2, and you would get the 2 arc angles there. And then from there, you can figure out y.
Very good. Okay. So let's take it one step at a time. Why is this arc the same as this arc, Sophia? The congruent symbols, okay? Now, one thing that happened that I'm not totally sure on was the fact that you said that this has to be 80 degrees. We don't know that that's congruent. So let's try to figure that out, though. What else could we use in this diagram? Stephanie? What angle is 90? This one and this one are both 90. Why are they 90?
So there is a way to prove that that would be 80.
You have a way to prove it?
If you would consider half the semicircle minus 80, that would give you 100.
Yeah.
And then on the other side, because the congruence marks are there, that would also have to be 100, leaving that top arc at 80.
You're right. Yep. Absolutely. Uh-huh. Okay, but hold on. Let's take it one step at a time. Do you guys agree? Because this is what kind of segment is this? A diameter that this angle has to be 90 and this angle has to be 90? Yes? We're cool with that? Okay. That means we can figure out this missing angle, right? What's 90 plus 40? And subtract that from 180. 180 minus 90 minus 40 gives me what? 50 degrees, right? So that means that this arc that's opposite the 50 must be 100 degrees. Xavier?
I did 100 minus 80 and got 100. Or 180.
Oh, because you saw it was a semicircle.
Yeah.
Yes. Okay. This is also 100 degrees because they're the same. And then this must be 80 degrees. Very good. Okay. Now, one assumption that I don't want you guys to make is that these angles must be congruent. Please, please, please write a note for yourself. That assumption is no bueno, okay? You can't just jump to the assumption. You had to make either Sophia's assumption, right, where she did the semicircle, she subtracted the 80 and knew that it was 100, or you had to use Xavier's, okay? But you had to make one of the two assumptions, okay? You cannot just jump to the conclusion, oh, they look like they're the same triangles. I'm just going to say that all the angles are the same, okay? That's not going to get you points. Yes? Oh, no, you're good? Any other questions? All right, this is where we're going to stop. Do you have this slide?
Yes.
Yes? Okay.